Hey guys, what's up? Might give me a 5 for 5 and we'll get this one done pretty quick, okay? I'm not going to stay on here very long, but I wanted to come out here and show this to you guys real quick. But yeah, so we 5 for 5? Okay. So I'm going to go ahead and just go for it here. Yeah, so first thing, guys, my live stream last night, I was showing you guys all these flares. Well, here's another big one, right? I don't want to call them big. They're not X class or anything like that, but I do think that this could have been, if it was facing us, this thing was on the backside of the sun. Well, it was around the limb. It was from that same sunspot that's been going off for forever. The one that was giving us all these flares in front of us. But this here is produced a massive eruption this time. So we're going to take a look at it here in just a second. But you can see how geomagnetic conditions here, we were impacted probably by a couple of these smaller eruptions we were talking about earlier this week. Nothing got us in the storm level, but I do think we took a couple glancing blows from some of those eruptions that were kind of off to our well, it would be west if you're looking at the sun. It's backwards, okay? So it'd be to your right if you want to look at it that way. But yeah, so again, guys, this thing is again, if this would have erupted 24 hours ago, or probably even more, maybe I'll rename my my video here. I was just trying to throw it together real quick. Probably more so like 36 or even 48 hours ago. If this thing would have done what it did, we could be looking at a pretty decent hit. But no, it didn't. So we're not. Just so everybody understands that right off the get. But this thing was pretty sizable, and it just happened. So there isn't a whole lot of data in yet. We have some. I got some stuff to show you, but Seeds hasn't updated hardly at all. Nothing, anything. Yeah. So, and they're usually behind a little bit here, and it's okay. We still got the data. We can go look at the data other places. But I do like showing you guys the difference imaging from the coronagraphs, the black and white one, because you're able to see a little bit more detail. That's the only reason why. As you guys can tell, I'm still sick, so I'm not staying on here long. Apologize, guys, but I can't do it. So, like I said, guys, I actually was going to go get my daughter from school. I woke up from a nap, and yeah, I seen that, and I was like, well, where did that come from? That other big sunspot is already around the side, right? It already crested the limb, kind of facing the backside. So I thought, well, maybe the one in front erupted, because we do have one facing us right now, and to my surprise a little bit, it wasn't. It was this one over here. And we'll take a look at it again, because on the 304 you can't even hardly see the sunspot anymore. But on the other imaging you can. Again, we're looking at different gases here. I believe the 304 is ionized helium. I believe. I have to go back and look at that. I believe that's what the 304 pretty much got you looking at here. Not that means a whole lot to you guys, but it just lets us look at different gases. Okay. So if we roll this, I'm going to go ahead and update that because, yeah, it's got a couple more images to show me here. So if I go here, and it doesn't look that impressive because, and this is something odd too that I noticed, the 304 is missing some data. The other ones aren't, but this one is. I don't, it's just I don't know why, but we don't have all the data. It jumps like a half hour, but the other ones didn't. So anyway, you're not going to be able to see a whole lot here on the 304. But I do want to show you something interesting too that I noticed right in front of us. We got a filament right in front of us from this sunspot. Well, that's a sunspot, but you got a filament kind of draping across here, and it's kind of interesting because it almost looks like it's coming from underneath the sunspot, just the way it looks. So let me just see if I can't get you guys a good look at that. Okay, now this one here was almost looked like a solar tornado. It's been there for a while. But you know, we've seen it way over here, and it for whatever reason, this is not very eruptive yet. It does have some characteristics where it could very well become eruptive very quickly, but it hasn't done so. Yeah, 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 you're right, Matthew. Thank you, though, for putting that in there. Appreciate you. Guys, go check out Matthew's channel. You need to. I tell you guys that a lot. Please, he's in here right now. Go check it out. He runs a 24 hours live feed. He's got some fiber optic stuff he was getting in. So I'm not sure if he's 100% up and running yet, but I know that he's still running his live feed. And the imaging over there is awesome. It's way better than what I can give you as far as detail. And when big events and stuff like happen too, he'll pop on for a few minutes and let you know. So, but you can see this right here, and we call this solar rain because you can actually see it raining back down to the surface. Okay, see that like that? It doesn't really look like that really ejected out a whole lot. It could have, I guess. I don't know yet. It doesn't look like it had any kind of like massive eruption, but I guess some of that could have released out. I haven't really looked. I'm just being honest with you. I haven't looked yet, so I'm not going to say it is or not. So, yeah, you're right, Matthew. It takes I mean, you're a whole lot smarter than I am, brother. I tell you that. A lot more knowledgeable when it comes to the technical part of all this. But anyway, so you guys can see that. We call it solar rain. It looks like it's raining. And what that is those are magnetic connection lines. And they're going back down to the surface of the sun. And the plasma travels on those lines. So yeah. Yeah, Matthew just said you got a short video showing it. So go head over there and check it out too, guys. I'll be done here in just a second because I'm not going to be on here long. Again, you see how it's kind of falling back down to the surface there? Most of that plasma did. Well, thank you, brother. Appreciate that. All right. Goodness. So, you know, on the 304, we're not seeing a whole lot here. At least I'm not. Let me back that off, and we're gonna take a look at it on the other angstroms here. But you can definitely see that it produced some X-ray, right? And you guys, you can see it comes from behind, right? Now it does look like it kind of, you know, the surface. It did come back across the surface a little bit, and maybe excited here a little bit. I can't really tell. It's right there on the edge, but some of this is being occulted. That's my point. All right, my point, and not all the X-ray are hitting us. So most likely, it's a lot larger of a X-ray producer than what we're seeing. You know, we can see it with our eyes, but our detectors aren't going to see the X-ray. They're just not, you know, they're being blocked by the sun itself. You know, so we're being able to see a lot of it, but not the whole thing. So, you know, we've been seeing this action from this sunspot for a while now, right? I mean, that's what's been giving us all the stuff this week. You know, I thought we were done with it, to be honest, because it was already on the backside. I mean, it really has crested all the way across the limb, guys. So when this thing erupted like this, and yeah, X-rays go out in all directions. So you guys have to understand that. You know, they're moving at the speed of light. They get here in 8 minutes. All the stuff that I talk about, but yeah, so when that pops out like that, you definitely see. I was like, well, is that really where that flare came from? And I'm looking at it. You can see it because you can see it's like gone. You can't even see the thing, and then it erupts, and you can see that. That's what really had me looking at the other tools, because I was like, because I looked at the 94 real quick because I was actually getting ready to go do something, and I seen that, and I was like, well, man, that looks like a pretty decent sized eruption, and I thought, let's go take a look at it, and sure enough, it's a full halo. Okay, not from our point of view, but from Stereo A's point of view, it's a full halo. From our partial sideways view here, and I'll show that to you here in just a second, but it produced a full halo. So whether or not that would have been, you know, a bigger flare, it definitely would have been bigger than what it came in at, because the X-rays, like I said, it got blocked. But as far as the CME part of it, you know, we don't really have a whole lot of way to gauge how big that thing is, other than the size. Okay, we can see the size of it because it peeks out around the occulter discs, And that's what gives it a halo look. And I'll show you guys that here in just a second. But you can see here on the 211 image, and this is from our perspective. I forgot to tell you guys that. This is SDO. It sits out in front of the Earth, always looking at the sun. And it orbits with us around the sun. It actually stays in geosynchronistic orbit above the same area of our planet in like a figure 8 pattern. So it's actually, rotating with us, plus orbiting the sun with us. Okay, I know it's kind of hard to put in your mind. I've shown you guys the graphs and stuff before. If you guys just Google SDO, and you can actually go look at exactly where it's at, it'll show its patterns. It'll show where it's at right now. But it always tries to keep its eye on the sun. So, but you can see that right here. It blows out. I mean, that's a decent sized one, guys. I want to mention this too. You see this? That's a big coronal hole too, and we're getting ready to be right in front of us. We're going to connect to that pretty quick. Like, that's probably going to give us some pretty substantial solar wind. We're probably connected to this one, I would imagine. I haven't looked, so that's kind of like right in front of us. So I would imagine we're going to start seeing in about 3 days some of these coronal holes giving us some fast solar wind, maybe some high dense solar wind, all the above, right? All the stuff we talk about. So let's take a look at this coronagraph. And again, I can't give you the difference image, the black and white, because it just hasn't updated yet. So I'm going to update that, and I'll just grab it here. It's easier to show you. Now this is stereo A, okay? And matter of fact, I'm going to do this before I show you guys this, because I want you guys to get a really good idea of where stereo A is, okay? Let me go to, and a good way to do that, guys, is to show you this NASA Enlil spiral. Okay, I'm not sure if that's showing that one or not. It might be showing that eruption, but man, I don't know, man, because that's an awful. That doesn't look that substantial of an eruption, and what I'm seeing on the other tools, it definitely looks like it's bigger than that, more intense. But anyway, this right here is a top-down view of our inner solar system. Earth is right here, the sun's here. This is stereo A. So it used to be out here, guys. So I mean, it's almost from our perspective now, but it's not. So we're looking at this thing, and you can definitely see it's like right in line with where that blew off. So we can see if there's a halo, and there most certainly is. So let me show you. Go back over here. Okay, so we're looking from the side here. That's what we're looking at right here with this imaging. These are other eruptions from the past few days. Okay, and we get down to, this is the 30th, and it's getting ready to happen right here. Okay, that's different. That's not the same one. And then right there on the end, you see that? Okay, so we got a full halo eruption. See how it's kind of distorted this way? Not only that, I mean, you got, this is a substantial eruption, guys. I mean, if this was coming at us, we'd be talking probably G2, G3. And it's hard to gauge it because it's on the backside, guys. I mean, there's really no way to do it. You know, they can kind of map out where the stuff is by using seismic technology now. They can detect, they map out the backside looking for sunspots and stuff using seismicity. Earthquake stuff that we use here on our planet. They can do this for the backside of the sun, and they're able to put together a model to give us a pretty decent look at where the sunspots are on the backside. So just so you know that, but we don't have nothing back there to really catch this CME like right in the face. So, but you can definitely see that. Now we'll go over here to SOHO, and this is another satellite. It's from our perspective, but it sits out about 1 million miles closer to the sun. Okay, and again, you're going to start seeing a little bit of a halo eruption. You're going to notice it's not going to be a full one because we've moved our perspective over. This isn't from the side. This is from our view, right? Let me update that. Okay, so we did. All right, so let me get down here. And again, these are different eruptions here. Okay. There's the bigger one. It produced a full halo there too. Okay. I thought it was going to, but I wasn't going to claim it till I seen it. Yeah. You guys can see that, right? Hopefully you guys can see that. See how it's kind of distorted there? I will and it takes up the whole camera here. So yeah, guys, that's a full halo from 2 different satellite views. That's a big eruption. So whether or not it would have been intense, what if it was going to hit us direct, if this would, like I said, this, I'm assuming, and I can't say for sure because I can't see it, but unless there was another sunspot that formed, it looks like it came from that sunspot that was giving us all the stuff this past week. All right, so you know, you can kind of see the outline here. I wish I had the difference imaging, because you would definitely be able to see it there. But you can see it well enough here, guys. I mean, and when we see these things, you know, those of us that look at these tools all the time, your butt starts to pucker. Because when you don't know if it's coming right at you or if it's going directly off the backside. Because the occulter discs here, that's a physical disc on the satellite. Okay? Blocks out mainly the corona of the sun so we can get a capture at all. So we don't know if it's coming right at you or right off the backside or going the exact opposite direction unless we look at the side view, which we already have. So we know that that's not, it wasn't shooting out this way because Earth would be over here. Okay? So we know it was going off the backside, plus I showed it to you on SDO. So we got confirmation it's not coming at us, so you know. I get that question quite a bit, and that's why I titled the video like I did, because yeah, I don't want nobody freaking out. But this was a massive eruption. It's a big one. Okay, and again, I can't tell you exactly what it would do if it would hit here. But what I can say is we would know it. That's a big one, guys. Plus, judging off of the other stuff that sunspot had done already, I guarantee you it was carrying enough energy that it could really give us a really good blast. Okay, but it's not coming at us, so you know we kind of dodged a little bullet here if you look at it in that perspective. You know, I hesitate to call it dodging a bullet too, because you know, in my opinion, the only time we're actually dodging a bullet is if it's actually going to hurt us in some way, right? Having a little bit of radio disruption and stuff like that, I don't consider that hurting us. Yes, it sucks for first responders and stuff like that use those radio systems, but it doesn't last very long on that end of it. GPS sometimes gets affected, but this also has some positive stuff for us. We get to see aurora and things like that. So, you know, I hesitate to really call it dodging a bullet, but, you know, I have no way to say how strong that would be. So, other than just going off of what that sunspot's done in the past. But you can definitely see that, guys. It was a big one. A full halo. You know, those, and again, from that sunspot, for it to produce a M-class flare behind the limb, any eruption with that, you've got to understand that would be substantial. I hope you guys really get that. And I'm not trying to like insert any kind of intensity, you know, be anything like that. I'm just being honest with you. I mean, that's what that is. So, yeah. So let's go over here real quick, and I am going to end this here in just a second, guys, so you know. Let's look at it on the 131 angstrom here real quick, because we get this does give us a pretty good look at the flaring whenever the sun flares. So you can kind of see it. Actually, that gives us a pretty decent look this time of this plasma leaving. Yeah, yeah, guys. I mean, so anyway, I mean, I don't want to add anything to it. It stands on its own. like they always do. You know, we don't need to add things to these things. They stand on their own. They really do. That's why I don't understand it when somebody tries to make it something it's not. Hey, Ripper, what's up, bud? Hope you're doing okay, man. So, yeah, guys, I mean, look at that. That's, yeah. So, it's not coming at us, okay? Again, whether you think that's a positive or a negative, I guess we'll never know because it's not coming at us. Yes, quite often, Matthew. Yeah, I agree. Hey, Leisure, what's up, bud? So, yeah, I mean, not really much more to show you guys, honestly, and that's why this is going to be a short one. I just wanted to bring that to you and show it to you. Now, I do think that this is that eruption, but man, I'm having a hard time thinking that that's all that eruption was. It could have been the one prior, and what I mean by that is, if we look here, we did see an eruption right there. You see that? So that might be what the NASA spiral's showing, and it probably is, because the NASA in-little spiral model doesn't usually update that quick. Okay, it usually has a minute. Hey, Siggy, what's up? Hey, Pamela. Yeah, there was one. Yeah, I think that's the one in the Matthew 8 hours before. So I think that's probably what we're seeing on the NASA in-little spiral. Wow. I get kind of sucked in by these things, guy. It mesmerizes me. But that's a big one. So again, it's not coming at us. Want to reiterate that again. Nobody needs to be freaking out. Like I said, guys, if there is ever a time I need to come on here and say, hey, you know, there's something really bad coming, I'm just going to say this. Chances are, if it's really bad, like, you know, SHTF type of bad, there's probably a 50-50 chance whether I would even be able to get on here in time. Okay? Just so you know. So, you know, and that's why I say that right at the beginning of of my videos, because I don't want nobody freaking out. There's no sense in fearing something you can't control. And if it is something that we need to be concerned with, I'm going to tell you that right at the beginning. Okay? Just so you know. But that's pretty much all I got for you guys. If it does anything else, I guess I'll come back on and let you know. But we will be watching this coronal hole. Oh, I tell you what. Let me go back over here. I did want to, because on the 131, it was showing what I was trying to show you guys here better than what the 304 was. Got this filament kind of riding across here. You'll be able to see that rain and stuff pretty easy here. See that? You can kind of see it tucking up underneath the corona. It's going back to the surface. Okay? That's a connection line to the surface, not to the corona. It's sucking up underneath. You can see that. It's a really good image right there, to be honest with you. We don't always get those views like that. See it? That's what we would call solar rain, guys. And it's nothing more than plasma just going back to the sun. That's all that really is on a magnetic connection line. When we call these solar vortexes or solar tornadoes, again, nothing's spinning, okay? It's a magnetic connection line, like I said before, but it just takes that shape. And when the plasma moves up and down on that line, depending on its polarity, it gives the appearance in a visual fashion that it looks like it's spinning like a tornado. It's really not, okay? There is no wind involved here, guys. Like you would think it was wind here on our planet, okay? So yeah, you can kind of see that falling back to the surface. I just thought that was pretty cool. Got a pretty good view of it. Now, again, here's that here's that eruption. Check it out. Yeah. The 131 doesn't oftentimes give us these good looks on that end of it like that. For whatever reason it is, this time it's picking it up pretty good. Man, that thing flared, and again, that's a long duration flare too. You know, that's one thing about this sunspot. It produced a lot of long duration flares. And what do I mean by long duration? I've explained that before. Sometimes you'll see a flare just spike up and spike back down, much like this one or this one. Okay, this is a long duration. That was a double flare, by the way. That's why you see that little trough there. I guess this one would be more of a long duration signature if I wanted to show it to you. But even this little small one, that's a long duration. You see how it kind of hung on, just kind of slowly tapered off. Sometimes we see the ones that are just one little quick blast, and then, you know, up and down. But these long duration ones, they actually have a better chance of sending us radiation storms and all those kinds of things. So yeah, but that's the deal, guys. I'm going to go ahead and pop off. Hey, Tommy. Hey, Verte. Hey, Linda. Guys, I am going to go ahead and take off here. Hope you guys have a good afternoon. Hope you guys, I know it's a weird time to be on here live, but that did happen. And I wasn't sure if I was going to have enough time or, to be honest with you, the energy to do it later on. But there it is. Okay. Let's just check it out one more time. Right there. Okay. And it did, and like I said, guys, it's not coming at us, but it did give us an M-class flare. And it looks like it did produce some small radio blackouts. I haven't heard no reports on that yet, but it gave us enough X-ray that it did put us into an R1. So, you know, I'm sure there were some disruptions. But, yeah. So, God bless. Hey, come check us out on the lifeboat later on tonight. We're going live at 8 o'clock. We're probably going to be talking about some pretty, well, intense subject and some stuff that people have some pretty good opinions about. You know, there's a lot of people on both sides of what we're going to be talking about tonight, I think. Unless the topic's changed or what have you, because sometimes we do that. We'll move it around a little bit. But it's a call-in show, so come on over there and give us a call. Or just come hang out, whatever you want to do. But we're going to be doing a live call-in show at 8 o'clock on the lifeboat, guys. So come check us out. And if anything else happens here, guys, I definitely will come on and let you guys know, okay? God bless. Yahusha saves. And hi to Sig Sauer. There you are, brother. How you doing, buddy? You can drink this Kool-Aid.